Assalamualaikum. My name is Nurmaisara binti Suhaimi, the final year student of Bachelor of Science Biology with Honours, will present my final year project with the title Physical and Chemical Characterization of Recycled Polypropylene-Bamboo Fiber with Palm Stearin Biohybrid Resin. This project was under supervision by Dr. Siti Asna binti Kamaruddin. Before we started, have you ever wondered what gives natural fibers the strength to replace conventional materials in real-world applications like car panels and building components? The secret lies in a simple chemical process like alkaline treatment, and today I will walk through how this process transforms from raw bamboo fiber into a high-performance material that not only stronger but also compatible with other polymer matrices. Based on previous study, plastic-based composites are commonly used in daily life because of their durability. However, these high uses of lead to plastic waste and pose environmental impact mainly targeted to effect on marine life or resource depletion. And this highlights the urgent need for sustainable alternatives. This study aims on developing eco-friendly composite materials by combining RPP bamboo fiber and palm stearin biohybrid resin. Through experimental analysis, the physical, chemical, and mechanical and thermal properties of these composites has been evaluated. This research addresses the global concern of plastic waste while promoting the use of renewable natural fibers. Aligned with the SDG 2030 agenda, this project contributes to reducing the dependence on conventional plastic and advancing the development of sustainable composite materials. There are two problem statements, which is the first is environmental challenges. The widespread use of synthetic plastic pose significant challenges such as pollution, resources depletion, and effects on marine life. Synthetic plastic are used everywhere but they don't break down easily. This leads to pollution, harms marine life, and as plastic waste piles up, it becomes a serious global environmental issue. Secondly, the limitation of biocomposite. The reinforced polymer with sustainable source help to improve the effectiveness of product flow while maintaining its usage as commercialized and sourced to depleted over time. Plus, it can help to reduce dependency on plastics. The objective of this study have two. First, to fabricate the recycled polypropylene bamboo fiber with palm resin biohybrid resin composite, and secondly, to study the physical and chemical properties of recycled polypropylene bamboo fiber with palm stearin biohybrid resin composite through experimental analysis. This is the steps producing the sample from scratch. First, the bamboo and RPP and palm stearin as plasticizer were prepared for composite fabrication. Next, we will do the sample grinding where the bamboo was chopped into small pieces and ground using a hammer mill. Third, bamboo fibers were submerged in a 6% alkaline solution for 24 hours at temperature room. Fourth, the mixing process of both treated and untreated bamboo fibers with RPP and plasticizer was carried out using a dispersion mixer. Next, the mixed composites were fabricated using a hot press machine at 180 degrees Celsius. And finally, the RPP, PF, and plasticizer composites were cut into standard size following a STM specification for sample testing. To fully understand the performance to develop biocomposites, several tests were conducted focusing on physical, chemical, thermal, and morphological properties. For the physical properties, the sample were tested in a density test and water absorption test. TGN and DSC for study the thermal properties of the sample. Next, the chemical properties, the sample were treated with alkaline treatment and undergo FTIR. And finally, the sample were run under SEM for morphological properties as the supporting result for this study. Result and discussion for density testing, RPPBF untreated has the lowest density due to presence of void and free spaces in the hemicellulose and chain polymer in the composite. RPPBFPS treated has the highest density, indicating the most compact and homogeneous internal structure among the samples. Treated bamboo fiber exhibit the cleaner surfaces and enhance the interfacial adhesion, which it reduces the voids and improves fiber dispersion, which leading to better packing within the matrix. Therefore, the increase in filler, which is bamboo and plasticizer concentration, combined with the proper surface treatment, improves the matrix compatibility and contributes to overall higher composite density. Result and discussion of water absorption testing. The lowest absorption was observed in the neat RPP, only 0.87%. Which is expected due to polypropylene's hydrophobic nature. The highest absorption was observed in the RPP-BF treated, which is 19.44% after 24 hours of immersion due to increased exposure of hydroxyl groups on the fiber surface after the alkaline treatment. The addition of plasticizer helped to reduce the water absorption slightly. This is likely because of plasticizer act as a void filling agent, and it's help to reducing the number of water accessible pathways within the composite. Result and discussion for alkaline treatment. The alkaline treatment mainly helps to improve any impurities on the matrix. As we can see from the figure 3, we can see that chemical composition like cellulose and lignin were reduced from the matrix after the treatment. The cellulose content has a higher composition in a treated fiber as is compared to untreated fiber due to the elimination of non-cellulosic components like cellulose become more concentrated, while hemicellulose has the lowest composition in the treated fiber as compared to the untreated one, due to its high solubility and alkaline solution, which causes it to break down easily. Lastly, lignin has a lower composition in treated fiber as compared to the untreated fiber. This is because the alkaline treatment disrupts its complex structure, allowing it to be removed from the fiber structure. There are potential applications that we can use from this biocomposite study, which to replace the conventional plastic. First is the automotive industry, like interior part of the car such as dashboard, glove box, steering wheel, and roof panels. These materials are lightweight, strong, and it helps to reduce the overall vehicle weight and carbon emission. Second is the furniture industry. It is to create a durable and long-lasting furniture components such as kitchen cabinet and interior design element. With their material with improved strength and sustainability, it also offers a natural aesthetics. Next is the sustainable packaging materials that are eco-friendly to the environment. It can be developed into biodegradable and eco-friendly packaging alternatives which helps to reduce the plastic waste and supporting the greener consumer practices. And finally, to create a perishable construction material and it saves money. Applicable for a temporary or perishable building materials like partition boards and panels. Not only is cost effective and renewable, it also reduces the dependency on traditional and non-biodegradable construction materials. From what we can conclude from this study is the recycled polypropylene RPP, PF, and PS biocomposite have been successfully fabricated. Secondly, this study able to demonstrate how incorporating green plasticizer, which is palm stearin biohybrid resin, into a recycled bamboo fiber and polypropylene composite can improve the material's properties in terms of both physically and chemically. Overall, the experimental result is likely to confirm that the feasibility of producing sustainable, biodegradable, and cost-effective composite which is aligned with the current global sustainability goal. From what we can recommend in this project is first, to extending a long period of physical testing by including the thickness swelling in a month that can be conducted to evaluate the long-term performance in a real-world environments. Next is using a natural fibers and biopolymer blends that can be explored to make a comparison between the performance and expand the applicability that may result in development of biocomposite production materials that are even more stronger and effective, not only the currently available materials, but also can be being sustainable. This is the list of the references. A very thank you so much for catching up and lending an ear.